Hi friends, what is pyrimidines? Pyrimidines is six-member 2 nitrogen containing heterocyclic compound. Pyrimidine was isolated by Gabriel. You know the pyrimidines are most important of all diazines. This ring system is found in living organisms. Mainly cytosine, uracil and thymine have been isolated from the malic acid hydrolysis. Purines and uric acid, barbiturate acid, alloxanes, and a mixture of antibacterial, antimalarial. Vitamin B also has the pyrimidine ring system. RNA, DNA, both types of malic and contains cytosine. Uracil is present only in RNA and thymine is present only in DNA. So, method of preparation, you know the two unit carbon 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 and nitrogen carbon nitrogen fragments are important for the synthesis of pyrimidine ring system. So, from malonic acid, the following steps are involved for the synthesis of pyrimidine. First, synthesis of barbituric acid. A simple synthesis of barbituric acid involves condensation between the malonic acid and urea in presence of a base. You can see the malonic acid, you can see the urea, you see the barbituric acid structure and their dynamic form. So, synthesis of pyrimidine, barbituric acid is converted into pyrimidine in the following steps. First, it reacts with the phosphoryl chloride, always converted into Cl, and finally, zinc dust water. You have the pyrimidine. So now the second method of preparation from malic acid. You know the malic acid is treated with concentrated sulfuric acid on decarboxylation. Malic acid form alpha formyl acetic acid which react with urea and forms uracil. Uracil can be converted into pyrimidine with the help of phosphoryl chloride and palladium carbon. The following steps are shown as. So you can see the malic acid treated with concentrated sulfuric acid and forming alpha formyl acetic acid. Further treatment with the urea, it gives uracil which is on dynamic. Further treated with phosphoryl chloride, you will get this, and then palladium carbon, you have the pyrimidine. Though amidines, thiourea or guanidine can be used in place of urea and condensed with 1,4-diketone. For example, acetylacetone condensed with benzamidine in presence of base give 4,6-dimethyl 2-phenyl pyrimidine. So acetylacetone, benzamidines treated with base, it gives this substituted pyrimidines. You know the urea may be replaced by aldehyde and ammonia. Pyrimidine is prepared by catalytic reductive dechlorination of 2,4-dichloropyrimidines. So you can see this conversion in presence of palladium carbon and magnesium oxide. Pyrimidines can be obtained by decarboxylation of pyrimidine 4,6-dicarboxylic acid. So you can see this decarboxylation. Pyrimidine can be easily obtained by the interactions of 1,1,3,3 tetra ethoxypropane and formamide in presence of alumina at 200 degrees Celsius. So you can see this is the cyclized products. Now pyrimidines can be obtained by oxidation of alkyl pyrimidine followed by decarboxylations. So, what is the reactions of pyrimidine? You know the boiling point and melting point. You can check it. It is neutral in solutions. It forms salt with acid, and it is resonance hybrid of the following resonating structure. So you can see that how many resonating structure is here. Now pyrimidine is less aromatic compared by pyridine and benzene, and dipole moment is 2.40 degree dBi, weakly basic as compared to the pyridine or imidazole because of electron withdrawing effect of second nitrogen atom present in the ring. The presence of alkyl groups or amino group increase is the basicity. 4-methyl pyrimidine has pKa 2, 4,6 dimethyl pyrimidine has pKa 2.8, 2-aminopyrimidine has pKa 3.54, and like this. So, in 2-aminopyrimidine and 4-aminopyrimidine, more resonating structure are possible in positive ion than in the neutral molecules. So, the resonance of the pyrimidine shows that pyrimidine has more electron density at position 5, but the attack by the electrophile is difficult, as expected, since the ring of the pyrimidine on the whole is deactivated. When the electron withdrawing groups such as OH or NH2 is present in the 2 and 5 or 6 position, the pyrimidine undergoes electrophilic substitution reaction, and they are tautomeric with the oxo and amino respectively, as shown below. You can see here the lactam form. So, the reaction with the electrophiles. Electrophile substitution reaction are difficult in pyrimidine at 2, 4 and 6 position. Due to electron deficiency, the attack of electrophile is retarded. Attack at 5 position is also difficult due to inductive effect of 2-nitrogen atom. If one or more electron withdrawing groups are present on the ring, the electrophilic substitution at 5 position is easily. So, the iodination of the aminopyridine has been investigated. On bromination, pyrimidine gave 5-bromo pyrimidine, and this reaction proceed via parabromic bromide intermediate. You can see the reactions of pyrimidine with the Br2. Now, nitration. If two electron releasing groups are present on the ring, electrophilic substitution become enhanced. You can see 2-hydroxypyrimidine or 4-hydroxypyrimidine, it is not undergoing the nitration, but 2,4-dihydroxypyrimidine uracil forming nitrated products. Now, sulfonation. If one electron releasing group is present on ring, direct sulfonation takes place at 5 position. Now, diazo-coupling reactions. If 2 or more electron releasing groups are present on the ring, the pyrimidine undergo diazo-coupling at position 5. Now, reaction with oxidizing agent. On oxidation with pyridic acid, pyrimidine gives N oxide is very small quantity. The ring is largely destroyed during oxidations, but alkyl pyrimidine on oxidation with hydrogen peroxide and acetic acid gave 4-alkyl pyrimidines N oxide. So, 4-methylpyridine, you can see the formation of product. Reaction with nucleophile. Attack by nucleophile at 2, 4 and 6 is greatly facilitated. Now, reaction with the Grignard reagent followed by hydrolysis and subsequent oxidation with KMnO4 in acetone gives 4-phenylpyrimidine. So, you can see the 4-phenylpyrimidine. Reaction with benzaldehyde in presence of base. If methyl group is present at 2, 4 and 6 position, the methyl group behaves as active methylene groups and may be changed into sterile derivative by conjugation with benzaldehyde. So, you can see the products. Reaction with boiling hydrazine. Pyrimidine reacts with boiling hydrazine rearranged to pyrazoles. So, you can see the products. If chlorine atom present at 2, 4 and 6 position is easily replaced by OH or NH2 groups, or if amino group is present at 2, 4 and 6 position is easily replaced by OH group by boiling with H2. So, these are the properties of pyrimidines, and you know my friend, pyrimidine, first we have to write to several times the structure, then focus on the position and then focus on the chemistry and position, reactivity, electrophilic, electron withdrawing group, electron releasing group, such type of permutation combination, then you will easily understand the reactions of pyrimidine.